Now let us define various terms that we will require while understanding the binary trees. So first thing that we need to understand what is root. So if I draw any tree, then any such tree would have a special node which is denoted as the root node, and this node will not have any parent. So for this node the parent is null, there is no parent. Okay, so this is the special node in the binary tree which we will call as the root. So if you remember the linked list, while representing the linked list, we just pointed to the head node and that represented the list. Similarly, to represent the binary tree, we will point only to the root and that will represent the binary tree for us. So once we have defined the root, we have to define what is child and what is parent. So when we build our tree, if you remember the definition that we had talked about, a tree can be empty tree, a tree can be a single node tree, or you can create a new tree by taking two existing trees and introducing a new node such that this new node becomes the parent of these two trees. Okay? And that's where the parent-child relation comes in. Okay, so if I give numbers to these nodes, let's call it 1, 2, 3, say 4, then there is 5, then there is 6, and let's introduce 7, and that's my tree. Okay, so in this case what is going to happen is 1 is the root node, so for 1 there is no parent. Okay, so let's list the parent relationship. So given node 1, if I talk about the parent function, parent of 1 is null. Okay, so similarly parent for 5 is 2. Okay. And then I will define the child relation and it will be exactly opposite of the parent. Okay, so if I define the parent relation, if parent of x is y, then it implies that the child of y is x. Okay, so for node x, if y is the parent, then for node y, x is the child. Okay, so if you have a list of parent relations, you can also know the child relations. So I can write that child for 3 is equal to 6 and so on. Okay, and please remember that this is not strictly a function in mathematical sense, because for some nodes there could be multiple values for child. For example, if I take node 2, it has two children, 4 and 5. Okay, so you can have multiple children. Okay, so if we define root, child, parent, we have to define now something called leaf. Okay, so just like root had no parent, leaf would have no child. So the list of leaf nodes in this particular tree is 4, 7 and 6. 5 and 3 do not qualify as leaf because they have at least one child. Okay, so we have to pick up only those nodes that do not have any children. So 4, 7 and 6. Okay, so 4, 7, 6, these are my leaf nodes. So once I have defined the leaf node, now let's define something called a path in our tree. I'm sure that you must be doing the discrete math course, and there you would be defining these terms more rigorously. So we'll say that in our tree, given two nodes, a path is a sequence of edges which are not repeated that connect these two nodes. Okay, so path would require two nodes, right? So I am asking for a path from say 4 to 3. Okay, so what is the way I can do that? Well, for that I have to go from 4 to 2, 2 to 1, and then 1 to 3. And in case of tree, we would have unique path between any two nodes. Okay, so you have just one path. We won't go into the proofs of these things because you are doing the discrete math course, and there you would be proving all those things. So path for the data structures purpose, we will say that in a binary tree, given any two nodes, it's a sequence of edges and there is no repetition of the edges. And using that sequence of edges, we should be able to reach from first node to the second node. Okay, so that's what we have as a path. And now we would define something called height of the tree. So basically, height of the tree is the longest path from root to any leaf. Okay, so I would ask question, which are my leaf nodes? So I have 4, 7 and 6. So I would have path 1 to 4. I would also have path from 1 to 7, and I will also have path from 1 to 6. Okay, and height of tree would be, out of all these, find the longest path. Okay, and when you define longest, you have to define the length of path. So length of path is simply the number of edges in the path. For example, if I take this path from 4 to 3, how many edges it involves? It involves edge 4 to 2, 1 and 1, 3. So 3 edges are involved. So length of this path is 3. Okay. So we would take these 3 paths. So let's compute the length of each path. So what is the length of path 1, 4? It involves 1 and 2 edges. So this is 2 edges. 1 to 7 involves 1, 2 and 3 edges. So this is 3 edges. And 1, 6 involves 1 and 2 edges. So out of these we have to pick up the longest, which is 3. So height of the tree is 3. Okay. And now we will define what is an ancestor, and then we will also define what is descendant. So now we know what is a path. So given a node, let's say I give you a node 5, okay, and I ask question, who are the ancestors for node 5? Then answer is that from the given node, find out the path up to the root, and every node that lies on that particular path, including the root, is the ancestor of that particular node. Okay. So 2 is an ancestor, 1 is an ancestor. Okay. In some of the books, they differentiate between ancestor and proper ancestor. So if you read some of the textbooks, they would say that for a given node 5, 5 to 1, all 3 of them are ancestors, but they differentiate that 2 and 1 are proper ancestors and 5 is not a proper ancestor. But we will not use that terminology. We'll say that if I look at the path starting from a given node up to the root node, excluding the given node, every other vertex on that path is ancestor. So we will not differentiate between ancestor and proper ancestor. Okay. So when we say ancestor in our course, we are talking about only proper ancestors. Okay. So again, a particular node can have multiple ancestors. Some nodes will have a single ancestor, which are those nodes? The nodes that are children of the root. They have just one ancestor. And then root has no ancestor. Its ancestor is null, empty. Okay. So now we have defined the ancestors. We will define what is descendants. So if I give you a particular node, let's say I give you node 2 and ask you, who are descendants for this node? Okay. So it is basically all the nodes for which 2 is an ancestor. Okay, so you can see that ancestor and descendant is generalization of parent child. Okay, so every parent is an ancestor, every child is a descendant, but it's not necessary that every ancestor is a parent. It's not necessary that every descendant is a child. Okay, so let's try to list the nodes for which 2 is an ancestor. Okay, so 2 is an ancestor for 4, 2 is an ancestor for 5, and 2 is also an ancestor for 7. Okay, so those are the descendants for 2, 4, 5 and 7. So basically, given any node, the list of descendants is all the nodes which are present in the tree rooted at that particular node. Okay, so that's the definition for descendants. Okay, so these are the few important terms that we would use frequently while discussing the binary trees. So please understand them well.